So I want to talk about something that's near and dear to my heart here, which is the developer story in this world of cloud native computing. I think we got a long ways to go, and I just kind of want to talk through some of the things that I'm wrestling with right now. I think the industry is also wrestling with, and then also propose a couple of solutions, and if the demo gods be with us, show some stuff that I think is building in the direction that I hope we can sort of take the industry. So first, before we do that, I want to talk just a little bit quickly about myself. So right now I run Microsoft's container portfolio. So things like our Kubernetes service, Azure container instances, service brokers, our upstream investments in Kubernetes and other projects. And I got to this place by obviously a few startups and things like that. But really my background is as a consultant. I worked in New York City for many years, helping, companies, mostly in the financial services space, try to become proficient with what at the time was very crude continuous delivery systems. So what I would say most of my career has actually been spent trying to empower developers, right? Now, this has taken a lot of different forms. Originally, this was a lot about, trying to take, folks who are writing enterprise Java inside of financial services companies and trying to get them to use crude continuous delivery platforms, based on things like, Debian packaging, old school CI systems like cruise control. I've been trying to get software pushed out to things resembling production environments. And so my whole career, I've been sort of building these automation systems, building distributed systems, but always with an eye towards what is actually working for the developer audience and what's not. And so now it's interesting because we have this new thing that we're all doing, whether we kind of realize it or not, which is we're building a new stack, right? I like to refer to this as the CNCF stack. The Cloud Native Computing Foundation is interesting on a number of levels, but I think the most important one is that this is the only place where all of the top 5 cloud vendors and really the entire ecosystem has sort of gotten together to agree on something since IaaS and VMs, right? We have Amazon, Microsoft, Google, Oracle, IBM, a whole host of other companies agreeing that, sort of Kubernetes is the de facto standard, container-based microservices are the future, at least for a big chunk of our app portfolio going forward. And we're all agreeing now to deliver things like managed Kubernetes services across all of our different environments so that, the net effect here is that we're raising up the level of abstraction and the level of, portability that folks can target going forward. Now, this is great, but there's also a lot of other work going on, right? Like this stack includes things like, how do you monitor stuff? How do you, get logging out of stuff? And so really the best way to think about what we're doing is we're assembling this group of building blocks. I remember when we first kicked off, I was at the first meeting where we were sort of proposing, the CNCF, lots of different vendors in the room. And, I'll never forget, Craig McLucky stood up and he had a presentation that was like this stack diagram. I actually tried to find it, I couldn't find it, but this diagram of what cloud native looked like and all the different interfaces between all the different components and the areas that we needed to solve. And it was a very neat, ordered view of the world. And I thought that was interesting. I thought that was aspirational. And unfortunately, I think despite all the good work that we're doing in the CNCF, from the standpoint of a developer, this actually really ends up looking a lot more like this, right? It's this big mess of Legos that folks are sort of forced to figure out how they're going to assemble in order to get something simple done. And these are things that developers have historically had really good answers for. I've got a little small service. I need to throw it up into, some production environment. The answers for how you used to do that with Java, build a jar file or a war file and sort of deploy it on Tomcat or something, right? There was ways to do this. And now what we've done is we've sort of said, no, look, there's this new stack. It's going to be great, trust me. But you're going to have to assemble all of these Legos. And so I think in practice what's ended up happening is that we've made this a lot better for folks on the operational side of the house, because things like Kubernetes are easier to operate, easier to sort of scale your operations function. But as a result, developers have been left out in the cold a little bit, a lot more for them to learn. So for me, when looking at things like this, I think it's really, really important for us to reflect on what the prior art is in this space, because none of these problems are new. All of these problems have, existed in computer science in the past, and we're just sort of solving the next set of problems over and over again. And for me, I think the most important thing to consider for prior art is developer-oriented PaaS systems, or what we refer to in the industry as APaaS, Application Platform as a Service. Now, systems like Cloud Foundry and Heroku are tremendously empowering. Who here has ever, used one of these PaaS systems, Heroku, Cloud Foundry, or others? Right, okay, great. You've seen what this can do for, production. I was recently giving a keynote at Cloud Foundry Summit in Boston. I was there talking about Open Service Broker. And after my keynote, I got to sit in the audience and I got to listen to these stories of Fortune 500 companies that are doing amazing things, transforming these relatively stodgy old enterprises into lean, mean, agile software writing machines, right? And doing it at scale across hundreds and hundreds of Scrum teams. It's really, really impressive what you can get with these application platform systems. So why aren't they succeeding, right? Why are we all talking about something else? And I think the answer is actually fairly simple. It's because at the end of the day, these application platform systems are providing black box abstractions, which is to say, these guardrails that they set up to make it really easy for you to build a 12-factor application, those guardrails are terrific. They're great. They're empowering up until the minute that they're not, right? All of a sudden, you have to bind to 2 ports in your application because you need a JMX listener for your Java app. Or you need to write out a little bit of state. It's just a little bit of state. It's still sort of 12-factor, right? But a little bit of state. No, all of a sudden you're kicked out of the 12-factor club. You can no longer use this platform. And so then the question becomes, when you break out of this abstraction and this PaaS layer stops, working for you, how far down the stack do you have to fall, right? So if you're using Heroku and you run up against the wall and you can't use 12-factor anymore, how far do you fall? You fall off the map. There's literally nowhere to go. You literally have to choose another provider, game over, start from scratch, go build it up on, Azure from the ground up, right? Now, if you're deploying on something like Cloud Foundry on, say AWS, well, in that case, you broke the abstraction. Now you get to fall all the way down to IaaS, right? Because you're already on AWS. That still hurts, right? Because you still got configuration management concerns. Dealing with IaaS and VMs is nowhere near as empowering as what you get out of dealing with a platform layer. So, while we were at Deis, we were really wrestling with these things. And so we built a PaaS product that it became extremely popular that was the first PaaS system to be built and really designed for, the key design principle was that it would run on commodity container orchestration systems like Kubernetes. So you could take, and actually it wasn't just Kubernetes, it was actually Docker Swarm, Mesos, or Kubernetes for a time. We actually made it work across the lowest common denominator orchestration. That turned out to be a terrible idea. Don't recommend that one. But we did make it work. But the cool thing about this was you could take any Kubernetes that you had anywhere, and you could drop another black box abstraction on top of it and get this sort of Heroku-like experience for your developers. And this has been extremely empowering, and this is extremely popular, still extremely popular today. And part of the reason why is, I talk about that abstraction when you break out of it. How far do you fall? Well, with Deis workflow, the PaaS project, you only fall down to the Kubernetes layer. And that's not far to fall. And the cool thing about this is when you fall down there, you can actually see all of the other apps. So if you're deploying PaaS apps on Kubernetes, they land in a namespace with Kubernetes Service Discovery. And if you want to deploy, something stateful using Kubernetes Manifest, a Helm chart, or something else, you can actually have those applications talking to each other on the same compute fabric, using the same service discovery primitives, things like service mesh, all of that sort of work in tandem. So this ended up being a really good answer, and it really sort of took off in the industry. But as I started, engaging more and more with customers, which a lot of what I do is spend time in the field with folks, what I started to realize was that there was really more of an interest in shifting to Kubernetes APIs as the primary focus, right? While folks loved the Deis, PaaS stack, they were really more interested in, how they could use Kubernetes to good effect. And this isn't really surprising. Kubernetes offers tons of things, secrets management, persistent volume support, great story for sort of operational lifecycle management, namespacing for logical isolation, lots of interesting things inside of Kubernetes for folks to take advantage of. Now, that allure, I would argue, started to take focus away from the developers and what was really best for the developers. But I think in the scheme of things, this ended up being okay. But as a result, I ended up working primarily with operations teams. Sometimes known as platform teams, inside large banks, inside transportation companies, lots of different industries. And as we started rolling Kubernetes out at scale, we started to derive a new operational pattern. This is something I like to refer to as the cloud-native operational model. Joe Beta actually gave a talk about this at the first KubeCon in San Francisco. The talk was called The Operations Dividend, where he outlined sort of this idea of the specialization of the ops function. And it's really fascinating because I've actually seen this play out over and over again in my career. So I just want to kind of walk you through what this means. So, how does Kubernetes and cloud native change the way that we think about IT operations? What you start to derive is at the bottom of the stack, you have this function of infrastructure operations. This is about taking raw compute, network, and storage and turning that into a service of some kind, right? And so this could be racking and stacking gear in a data center. Commonly you got people doing that and turning up racks. Or this could be outsourced to IaaS, right, where you just go to your IaaS provider for compute network storage. And that tends to be best run as a separate layer of folks who deal only in that, around the compliance for that, capacity planning, things like that. The next layer up is you're going to have to figure out how to tie that compute network storage into a set of APIs that are developer-oriented in nature, right? How do your developers now consume compute network and storage APIs? It turns out that if you do this long enough, you're going to derive a separate operations function that is just purely focused on doing this for a living, right? Think of this as Kubernetes cluster operations team, right? We see this over and over again. They're all usually called platform teams inside other companies, but there will be a team whose job it is to not necessarily work with IaaS or rack and stack servers, but whose job it is to make developers do their job faster, better, more securely, right? And so that cluster operations function ends up being pretty important. But now what's cool is that if you don't want to do this, you can actually choose from a suite of Kubernetes as a service providers, that are offering Kubernetes managed. Azure's Kubernetes service being a good example of that, right? So this is another area where you can outsource. Now, here's one area where you can outsource: application operations at the top. It's important to remember that for a high-functioning organization, you're never going to be able to outsource certain kinds of operational duties at the application level. For example, how do you monitor your application? What are the business metrics for your application? Do you care about requests per second? Do you care about shopping cart abandon rate? Like, what is it you care about for that app? How do you do deployments? How do you, run canaries? How do you alert when something goes wrong? There's a whole set of operational concerns at the application level that are important to make sure that you're covering. Now, this is what I like to refer to as kind of the traditional DevOps model. Developers and operators sort of working in tandem, right? Now, the problem is that that's not actually how this works in most companies, in my experience. This is how it works for advanced companies. In most companies, if you work in operations, your job is all of it. You do all of this. You rack and stack servers or provision IaaS. You glue those servers, network compute storage, into something resembling a cluster. You deal with software teams on how to operate your application, how to monitor it, how to do telemetry for it. And it is too much. And we are not going to be able to succeed as an industry if we don't arrive at some level of specialization for the operations function. So this is really, really critical, and I think that, as I said, higher functioning teams, as you start to get more proficient in this, you end up deriving this. But it's important to start thinking about this and how you can potentially bend your organization towards this model. So really what we're talking about at the end of the day is that at the top of the operational stack here, we're really promoting a you build it, you run it model for software development teams, right? This is really the goal for the industry, I think. So I want to talk a little bit about how, what are the elements of, you build it, you run it. How do we, get here, right? So version control is, I think, a key component. So let's talk for a second about how version control plays into the mix here. Who here has heard of the term GitOps? Okay, a few of you. So GitOps is the idea that if you're going to be operating, anything really, clusters, applications, anything like that, you really want that desired state stored in version control so that you can run, a CI/CD pipeline off of that state, right? You'd be surprised how many people are not doing this today. Even high-functioning enterprises do not necessarily have a way to track and version things in a repository like Git. Now, this isn't just for recoverability reasons or source of truth reasons. There's actually a very important function that GitOps provides, which is the ability to have a discussion about changes on a pull request, right? Your change review process for how you change things in production should be discussed and reviewed just like any change in your source code. And if you're not running these changes through version control, you're not going to be able to do that. And that ends up being a problem. So the question becomes, okay, great, I want to do this, right? How do we do this? Now, in the wild, we see two approaches for how folks are using GitOps. The first one is what I would refer to as an Ops-centric repository. The idea here is that development teams are sort of building artifacts and tossing them over the wall to an operations team who will then take those artifacts, put them into a set of manifests, and then there'll be sort of this one, maybe a monorepo or a set of different operations repos that will be used to construct a production environment. Now, normally developers don't have access to this repo. Or they're certainly not allowed to merge changes into that repo. Sort of heavy operations controlled environments will derive this. Also small companies where you have one operator in charge of rolling things out to production, you might find this sort of ops repo pattern. Now this works. I've seen it work at scale. This isn't what I prefer. What I actually prefer is what I would call the app-centric repository. This is the idea that alongside the source control for the service that you're building, you actually store your deployment configuration, your Kubernetes manifests or whatever it may be, and you have discussions as a software team on how you're going to roll out changes to production. This will often manifest as a branch per environment. Where pull requests will happen into a branch, you'll have a discussion on that, that branch will get merged and things will sort of roll into your CI pipeline from there. Now, again, there is no right or wrong answer to this other than making sure that you have this stuff in version control. Because if you don't have it in version control, it's chaos. So talking a little bit about, okay, we got these repos. Now, how do we get code into them? So if you think about this from the standpoint of a developer, I have a new repo. I'm writing a .NET Core application. And I want to do this cloud native thing, right? How do I actually go about doing that? And we're starting to see this new approach in the industry called scaffolding, which is very different than a black box abstraction. So it goes something like this. You start off with a detection heuristic. Now, if you've ever used something like Cloud Foundry or Heroku, you'll know the concept of a build pack. And one of the first things that a build pack does, you sort of git push or CF push into the system, it will take a look at your source code repo, and it will run a heuristic on it that will say, oh, okay, I know this. This is a Java app. Oh, I know this. This is a Node app. And as a result, it will know how to treat that app and sort of prepare it for deployment. Now, that works great for a PaaS system, but what we really want is we want that sort of containerization of the application to land in version control, not in some black box build system, right? And so detection heuristics here, draft is something that we built in the Azure team that will offer a configurable heuristic where you can write your own, sort of think of it as a build pack, but they happen to run client side. And what they do is after you detect that it's a Node app or whatever kind of app, you will have a default file system layout that you will sort of throw down into that repo, right? This will typically include things like a Docker file, a Helm chart, a CI config, something like a Jenkins file, a set of defaults that is curated by your operations team in order to allow the developer to just run this heuristic and then just kind of get everything they need to containerize their application by default. Now, this works great in practice. I've actually seen this work great. Draft is a wonderful way to do this. But what's really important is that this is not just, there is not one answer to how you want to do these file system layouts. This is contextual. This depends on your organization. So it's critical that you have some form of centralized management around this in order to make sure that you're able to scaffold with some control centrally. So the next thing I want to talk about is the development process. So inside of the development process, we talk about two things inside of Microsoft. We talk about the inner loop and the outer loop of development. The outer loop refers to after you've sort of pushed some code to your version control system and your CI and automation system takes over and things start to roll out to production. Now, I'd argue that this is pretty well solved. I'd actually argue that this has probably been solved for like months now. There's 100 different ways you can do this. All of them are quite good. What's really more interesting is the inner loop of development. The inner loop refers to the period of time when a developer is working on a piece of code, but before they've committed that code to version control, and pushed it up, and after which the outer loop process takes over and pushes code out to production. This has been notoriously neglected. And I would argue that this is the reason why developers are so damn confused right now, is because no one has told them how to sit down at the keyboard and actually start writing an app that's going to target a Kubernetes cluster. Now, assuming you get things like scaffolding in place that can start to solve this problem, the next important thing to cover is how do you test during the inner loop? How do you know that while you're working in inner loop, you're actually going to be safe? Because you don't want to push to your CI pipeline and have everything go red every single time you do this, right? So the thing I've been promoting is this concept of unit testing locally, right? Like unit testing is, it's an art. It's important that folks are doing this regularly and doing it on their box, on their laptop. The problem is that unit testing is only going to cover so much. And when we start to talk about complex microservice environments, you really need to get into a system where during your inner loop, you're integration testing your changes remotely. Which is to say that you have some way to plug your laptop or whatever you're working on, to write code into something resembling your production environment so that you have some level of confidence that the change you're about to introduce is actually going to fly in something resembling your production environment. It is too difficult to mock things on your laptop. There is not going to be enough memory in the world to run on your laptop. Furthermore, you're never going to get Cosmos DB or any of your other cloud-based dependencies to work on your laptop. So while in theory it'd be great to set up a bunch of mocks and have all this work, in practice it ends up being really, really difficult to pull off. So we'll talk more about that in a second. But after the inner loop testing is done and you've integration tested remotely, at this point you commit and push to your version control system. You get off to CI. Now, a couple of things I've learned. The first thing is that keeping your CI configuration in your repository is important. You need to keep this versioned along with version control. That's why things like Jenkins files are taking off. Circle CI, pretty much every CI system is keeping config and version control. I do still see a lot of people configuring Jenkins sort of out of band and dropping Jenkins jobs configs that are not in version control. If you're doing that now, stop, right? Just get this stuff in version control and make sure you're having pull request discussions anytime you focus on, anytime you're modifying CI. Now the next thing is artifacts, right? I started building CI systems really early, and back in the day, CI was never about deployments. CI is really about taking a SHA or a change in version control and spitting out a set of artifacts. That's its goal. At some point along the line, someone decided that we were going to tack on a deployment at the end of that thing. And the green, hey, my build passed, now equals my deployment passed. And that is convenient and it works for people. And I know this is a little bit controversial, but I actually don't think this is architecturally sound. I actually think it's really important that we as an industry start to think about how you decouple CI from CD. There are cases when you start to operate at the scale that Microsoft operates where you don't have a sense of your deployment topology, at least a sense that can be tracked in version control, right? What happens if you're dealing with, as Microsoft, we have the largest number of regions in the world, right? They're always changing. There's always new things happening in every region. If I had to go track every region in our CI for what we want to push out to, we would be constantly updating our deployment targets. I would argue a better approach to this at scale is to actually focus on building artifacts and then have an asynchronous pull-based model for doing your continuous deployment and continuous delivery out to production. Now, think about an IoT environment where you have 1,000 devices that you need to target with your updated piece of software, right? You start to think about how you can sort of break this down into an asynchronous event-based model where your endpoints are polling for changes rather than actually having something like Jenkins centrally pushing those changes out. Now, even if you're not going to do that sort of event-based model today, just making sure you have a nice clean boundary between what is CI and what is CD, I think that's probably a good starting point at the moment. So just to dive into CD here, what is the purpose of this? Well, the purpose of continuous deployment is to make it safe to deploy to production, right? And so there's a couple things that we end up doing in this case. The first is having smoke testing as part of your continuous deployment, right? Imagine a world where you had an evented model where you were listening for a Docker image to land in a repo, and based on the name of that Docker image and a regular expression on that Docker image, you would either decide to promote that change or not. Well, if you have a little bit of smoke testing on the endpoints before, as part of your rollout to production, you are increasing the likelihood that your change is not going to cause a massive disruption as you roll out to production. These are things that you can't necessarily test at the front end of your CI process. So don't test them there. Move that testing logic into your continuous deployment pipeline. But think about that CD pipeline as a separate thing. The next thing is feature flags. Who here uses feature flags to deploy to production today? Okay, I would hope for a lot more hands. Feature flags is a very, very important part of delivering software at scale. The idea is that basically you put conditional logic, branching logic into your code, based on HTTP headers or different things, and you allow for a deploy to production with a new feature, and then you allow someone with a special key, HTTP header, custom URL encoded, endpoint to be able to start testing that feature before you actually roll it out as a default in your application. Lots and lots written about feature flags, but this is an important part of constructing a reliable, scalable CD pipeline, is making sure that you are instructing your developers with how they should be using feature flags and deploying them at scale. And the last thing, and this is something that I've been spending a lot of my time on, which is the idea of Canary deployments. Now, Canary deployments are something that everyone wants, but no one is really doing. In my experience right now. Or let me put it this way, very few people are doing it, and the process for doing it tends to be very manual. I would argue that in order to truly empower developers, we need to make Canary deployments completely automated. And I would argue that it is actually possible to do this. And we'll talk about this in a minute. But who here is doing Canaries? I'm just curious. Canary deployments for their environment. Okay, a few hands. When you work at Microsoft scale, we don't have a choice. We have to do Canary deployments. We have to test that, if we're rolling out a change to AKS, that we get 2% of the traffic on that change, and 10%, and what we call safe deployment practice. Right? We don't have any choice. Right? This is best practice. Now, how you do Canary deployments and how you automate Canary deployments for the masses, for a generic use case, comes down to observability, right? Because the way you canary something depends on how well is your application performing, right? And so I'm looking for a few things here on the observability front. Obviously, this is a huge topic, monitoring and observability. You could go on for days, but specifically, I just want to focus on a couple of things that I think are necessary to get developers empowered beyond where they are today. The first is I think we need instrumentation for free, right? I think that there is a way, specifically with technologies like Service Mesh and Istio, to get key observability metrics into the hands of developers, or more accurately, into the hands of something like an automated Canary system, that is going to really allow folks to leverage the benefits of Canary deployments without having to code anything custom. And so you think about what's involved for the generic form of a Canary, right? The first thing is a sense of request throughput. How many requests per second are running through your application, right? Because if you don't have any requests, your Canary is not going to be extremely effective. So for example, if you threw a feature flag on there, and none of the traffic is routing through your service, whatever other signal you have is not going to be very good because there were 0 requests testing your app, right? So this is a pretty important thing. But the good news is things like Istio, Service Mesh technology, can give this for free out of the box, part of smart pipes, right? The next one is request latency, right? How long is it taking your request to process? And more importantly, how has that request latency changed since your last deploy? Or since other services that are part of sort of the service deployment topology? This is something, again, we can get as part of something like an Istio. And the last one, and I would argue the most important one, is error rate, right? What was the error rate prior to this change? What is the error rate after this change? Now, if you can get these things, request throughput, if you can get request latency, and if you get error rate, and you can get those generically for any application that you're deploying, I would argue you have enough signal there to be able to drive a Canary-based controller inside something like Kubernetes. And this is something that we're working on, and I hope to be delivering something here soon. Now, the lead PM for AKS has this great quote that I love, which is, modern applications are sufficiently complicated that they need to be flown by the instruments, right? The idea of fly-by-wire for your application workloads. And I think it's extremely true, but I actually don't know many companies that are doing this yet. And I think that in order for us to get developers empowered the way that we need to empower developers, we're actually going to need to deliver this one way or another. So the question now for me is, we need to do something great. We need to do something big in order to get the next crop of developers to build on top of this stack, right? So what are we going to do? How are we going to do this? Well, I think there's a couple things that I'm personally advocating for at this point. The first is, let's promote white box abstractions over black box abstractions, right? Scaffolding of Docker files, Helm charts, CI config into a repo is better than CF push. Why is it better? Because it allows the developers to get the same experience of onboarding quickly, but they can learn at their pace, right? Because once that stuff drops in their repo, if the developers have time, developers are curious creatures, right? If they have time, they're going to go, what is this thing that I just committed to this repo, right? Oh, it's this Kubernetes manifest. I wonder what that is. I'm going to put a little note in to go read the docs on that thing. What's this Jenkins file thing? Oh, this is how we do CI. Well, I'm going to put a note. I'm going to go read about that later, right? And by doing this, we're starting to empower developers and allowing them to learn, because they are going to have to learn this stuff eventually in order to deliver on the you build it, you run it contract that we're promoting here. And by by protecting them with a black box abstraction, all we're really doing is preventing that learning from happening. So the question is, let's let the developers learn at their pace, but let's get them going quickly, right? The next thing is what I talked about is automate Canary deployments, right? When a developer is done with their inner loop and they commit and push, we need the safe deployment practices to be 100% automated, right? The industry's got a lot of work to do here. And I would argue this is not a Microsoft thing or anyone needs to control this. The industry needs to figure out a way to solve this, likely using service mesh technology, so that deploys by default are following some level of Canary process. And I'm optimistic that we're gonna get there soon. The next thing is, on the observability front, we need to deliver contextual dashboards. I am a big CLI person. I love me some CLI. Right? If I could live only in a terminal, that's where I'd live. That's not where the majority of developers live. Majority of developers I want to target are very into graphical interfaces. And there's good reason for that. Contextual dashboards give you the ability to do drill downs, to do things like access logs or look at monitoring data or get some visuals on what's happening in your deployment environment. If we don't focus, or start to shift focus from CLI-based tools to graphical-based tools, we are cutting out a large part of the population who requires these graphical interfaces. So, remember, though you may prefer CLI like me, do not disparage folks who want to use a graphical interface for this stuff. It is important, and we need to do our job in delivering this. And then the last thing I am big on here is I want to make it safe to develop in production. Now, we're not here yet, right? I think it's still pretty risky to do this. But if you look at some of the really high-functioning organizations, the Twitters, the Ubers of the world, right? Those systems are so complicated that there is literally no way to mock that stuff on a laptop. And so you literally have to develop in production. There is no choice. And I would argue that we all need to come to terms with the fact that, yeah, we bought, a 3,000 US dollar laptop and we want to develop on the airplane and we want to do all that stuff. It's not happening, right? You're going to have to get comfortable developing in the cloud, in your production system or something resembling your production system. So the question for us as folks who are building in this industry is, how do we make this safe? For folks. And so we've taken some cuts at these problems, and if the demo gods are with me, that's me about to get stepped on by the Wi-Fi here, we will see if we can show a little bit of this. So what I'd like to show you is a product that we just announced called Azure Dev Spaces. Now, there is a really good chance that this is not going to work over the Wi-Fi, so I have a video to show this in case it doesn't work. So let's set the stage here. Hi, my name is Gabe. I just joined, thank you for welcoming me. I just joined the new smart hotel company. I'm a developer, it's my first day. And I've got a bug that I need to fix in this. This is our app. Now, if I go into my AKS cluster, I can see here that, go into the health view. See if the Wi-Fi is going to work. I can see here that I have a 3-node cluster running lots of different containers on it. This particular service has about 10 or 12 different microservices that are part of this service. Right? So this is a standard sort of application model. Now it's my first day here, and I have a bug that I need to fix. And I want to impress my boss, so I want to fix this bug really fast. So let me show you what the bug is. So this is a hotel registration website, and if I type in New York, I can see that I can select New York, and I can go book some time, and I find a room, that sort of thing. But we have this big event coming up in Seattle, and what I realized was that if I type in Seattle here, I don't get any results back. Uh-oh, we got a problem. And so this is the bug that my boss asked me to fix. I want to go fix this thing. The problem, though, is that I got 13 services in this environment, and I'm pretty sure that this service is like 2 layers deep in the microservice call stack, right? We got front-end API and some other stuff involved. So I have to figure out how to debug this, but I don't really have time to go set up this entire development environment. right? So how am I going to do that? Well, the first thing I'm going to do is I'm going to open up my IDE here. Actually, I'll try to do this in a terminal so you can see it. And I'm going to run this command azds Azure Dev Spaces space create -n Gabe. Actually, I already ran this before, but what that's going to do is that's going to create a Kubernetes namespace in my cluster for me. And it's going to allow me to do a little bit of remote debugging. So let's see, if I open up this cities controller here, I was told this is roughly the file where this thing lives. This code is written in .NET. I actually don't have .NET loaded on my laptop, but let's see if I can debug that anyway. So if I just go ahead and drop a breakpoint right here on the return of cities and hit F5 to debug, here's where we see if the network is gonna play nice with us. All right, it looks like it's playing. So what's going to happen is it's going to ship up my changes to the cluster inside of a container that's running in the cluster, and it's going to pop a remote debugger in this environment. And at this point now, because I created that space using the dev spaces command, I can actually do this cool thing where I type in gabe.s on the prefix of my URL. That's saying I want to talk to Gabe's space on this environment. Now, if I hit enter, what's going to happen is I get the same website, right? I'm hitting the same front end. It is actually the production front end of the service that I'm hitting at this point, right? But when I type in Seattle, what will happen is it's going to pop a breakpoint on the production environment because it actually shipped a version of the container that I'm debugging into the cluster just for this one service, and it configured a service mesh inside the cluster to route traffic just to this service so that I can run breakpoint debugging on just this one service while keeping the rest of my microservice call graph and all the backend dependencies all intact, right? And so now if I go into the debugger, I can look at a call stack. You know what's really funny to me? It's almost like when we started doing containers, people forgot about breakpoint debugging. Like it was like we just collective amnesia. Like everyone was like, "Oh yeah, breakpoint debugging, that's dope." And then, "Oh yeah, print line debugging, that's the only way we can do any of this stuff, right?" And it's interesting, right? Because we weren't able to do that kind of thing safely in these environments. Containers sort of threw a wrench in it. It's time to get back to that. So we can see here the results are empty. And actually, if I look at this query, I can see that we're getting default cities. But if I go and actually do what we should have done before and query the database, actually, sorry, let me just hit play on this. And so we can see that, the query should return here null. If I go ahead and save this and restart my debugger, come on. Who's using the Wi-Fi? Who's downloading a BitTorrent file? All right, there we go. Actually, this breakpoint debugging session brought to you by the East Coast of the United States. So not surprising, it's a little slow. So now I go back to my space, and I go ahead and hit refresh on this thing. And now I type in Seattle. And now, because I have this database query involved here, I should get a different result. If I look at my cities, my count equals 1. And I can actually see in here Seattle is returned. So if I go ahead and hit play, I can see Seattle is now here in the United States. Yay, it works. So, obviously this stuff is still really new. This product in particular is in private preview. We're going to be rolling this out sooner. But, the hope here is that, by making it safe to do this kind of debugging in production, we can allow developers to do things that they used to do back in the 90s on today's modern cloud data stack. How ambitious of a goal is that, right? But really, after the developer fixes this bug, they should be able to commit and push. And the thing that we're really missing here, in my view, is that deploy should be automatically canaried, right? The developer shouldn't have to do anything with that commit and push to production. I think if we can get there, we can do a lot to level this game up for average developers. So, just a couple other things here to wrap up. So where do we go from here? Well, I think that in order for us to be successful at empowering developers, we need to accept that there's complexity in the stack, right? That pile of Lego building blocks, that's actually a good thing. That refers to principal composable architecture. And it's that kind of effort, and frankly, the peer review that happens in the open source community that means that the stack that we're building in CNCF is not going to just last 3 years till the next hype cycle. We're talking about building software that's going to last for 10 years, for 20 years. And that requires that we accept some level of complexity. Distributed systems are hard. Anyone who tries to tell you that, oh, I got a really simple solution for, that Kubernetes thing, that's way too hard. I've got this, 100 lines of Go code that are going to fix this thing. They're full of it, right? Okay, so we need to accept that there's complexity in the stack. But at the same time, we need to demand simplicity for end users. If we are doing the layering properly, we do not have to expose the end users to more complexity than they need. Although I would argue some amount of slow exposure to concepts is actually long-term beneficial to this environment. Now, I was reading an article the other day about how many stars there are in the observable sky. And it turns out that there's only a little bit more than 10,000 stars that you can observe with the human eye. Isn't that kind of crazy? I thought that was pretty crazy. I thought it was a lot more than that. You think about how many developers we have today in the world. The studies vary, but everyone is in agreement that there's going to be somewhere on the order of many tens of millions of developers that are going to be entering this world of computing over the next 2, 3, 4, 5 years, right? Tens of millions, maybe 100 million developers, depending on how broadly you define developer. If we don't do better to solve these problems and promote simplicity for end users, allow for things like breakpoint debugging, make things like automated canaries possible, we are going to be doing a disservice not just to these developers, but I would argue to humanity at large, right? Because there's a lot of ideas that these folks are going to be bringing to the table that we want them to be able to share through the vehicle of software. So let's focus on empowering developers. Let's focus on building tools that can hide and mask some of this complexity. And let's try and do a better job for the generations and the young ones that are coming up trying to be a developer in the cloud native space. That's it. Thanks, everyone.